Well, hello everybody. What's my camera doing? Is it a bit blurry? Okay, let's test sound. Oh, camera, come on, man. Let's change this connection. But how am I sounding? How am I sounding? Put your thumbs up if you're here. Let me see you. Let me just change my connection. Let's change the connection. Get a stronger one. Okay, let's test the sound. How am I sounding? I'm looking better now. Yeah. Yes. Which side should I? Oh, I don't want to show my tooth. Okay. I think we're looking good. We're sounding good. We can get ready to get started. Tiamo, I see you. Welcome. Welcome. Let me just write it down. Um, sorry. Put your thumbs. Is it thumbs or thumb? Let's go for thumbs. Thumbs up if. Oh no, to show me you're here. To show me you are here. Put your thumbs up. Yeah. Well, how we doing, everybody? Are we ready for our test tomorrow? I hope you've been studying. Yeah. I see you, Tlotlo. Welcome. I hope you've been studying and getting ready. Today we'll be just doing a quick revision of everything that you have learned. We'll do a paper that I've prepared. I will show it to you momentarily. Welcome, Selekane. Welcome, Tsireleto. Welcome. Yeah, like I said, I've prepared something for you guys. Welcome, Snetemba. I've prepared something that we can do. Now, I've prepared 3 topics. These are the 3 topics that you will be writing on. If you saw the scope, it included stats. Well, I can confirm it for you if you didn't know. Stats will not be in the paper. Stats is not in the June examination. Okay. Welcome, Onka. Welcome, Letabo. I see you. Welcome. Stats will not be there once again. So I hope you have not been studying stats. But if you were, well, it's a good idea to always have knowledge, I guess. Welcome, Gerard. Welcome, Neo. I see you. Neo. Welcome, guys. We'll get started in 2 minutes. I will project the questions that I've prepared. I've prepared a questions on analytical geometry. I've prepared also on trigonometry and also on Euclidean geometry, just like it shows in the poster. Yeah. Well, sorry for releasing the poster so late. I hadn't planned to do this because there were other plans in place, but those plans didn't pan out. So here we are. We're together now. We're going to do this paper, and hopefully you learn or get reminded of something that you had not studied or something you had forgotten, something you will need tomorrow. Since you're writing tomorrow, I think it's too late to learn something new. These should be just reminders. So, just like before when we were doing paper 1, if you get the answer before me, I do actually encourage you as I'm doing the answer and you know exactly what to do, you should do it as well. Okay. Other than that, and if you pop it in the comment section before I finish it, well, I will thank you very much. All right, let's do a little bit of shout outs. Welcome, Gerald. Welcome, Neo. I see you. Welcome, Neo. Bokamuso, welcome. Welcome. You are most welcome here. Oh, that's my wife. To the Fed. So I still struggle to pronounce my wife's name. Um, yeah, yeah, because as you know, I'm Guni. I speak Siswati, and I identify as a colored because my dad is Swati, my mom is Zulu, so I'm a colored. Yeah, that's why I identify as a colored. Who's this? Wow, love. Yeah, it's your first time hearing me say this that I identify as colored. Well, yeah, well, first time for everything. Oh, yeah, are you laughing at the fact that I can't pronounce your name? I'm not sure what you're laughing at. But anyway, let's get the show started. Okay, let me project the question for you and then explain something on how we are going to be working this thing out. All right, that's my screen right there. Okay, so on the left, I've got the questions. And on the right, this is where we will be doing the memorandum. So as you can see, we're doing Euclidean, trigonometry, analytical, not necessarily in this order. We'll do it in the order of how the questions will come out tomorrow. So the questions will start with analytical, trig, and just to show you briefly what we're doing, this is analytical question 1, question 2 as well, circles, question 3, that's where we start trig, question 4, more trig, question 5, more trig, question 6, more trig. Trig holds a greater chunk of your marks. Okay, and then question 7, that's when we'll start Euclidean. These are the questions we'll be dealing with up until question 9. Now, I really hope we'll have enough time to finish this paper because we only have 2 hours together, and then we'll end the session. If you want this paper and the memorandum, I can always give it to you, no problem. Just pop me a message, a WhatsApp, and I'll send it to you. Now, let me just switch on to my phone so that um, I can see your messages here, your comments.
I can see your messages here.
Okay, I see your messages already. Welcome, Onka. You can push 3 hours. Say no, 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 no. I cannot push 3 hours. Absolutely not. I myself am not writing the exam tomorrow. Only you should push 3 hours, not me. I'm not writing. I get tired at about 1 hour 45 minutes. I'm tired already and I want to go and rest. But not you. You are much stronger than I am, so you can definitely finish it in 3 hours. Welcome, Heteko. Yeah, I'm sorry for butchering your name there. Okay, so it says here in the diagram below, A is -5 and 1, B is there. Okay, I see B, there it is, 1 and 6. C is 7 and -2. These are vertices on the triangle ABC. With, does it continue? It's very important to read the statement, guys. It's very, very important to read the statement. And then it says BA produced to E. I see BA, there it is. It's produced to E. That just means it's a straight line. Welcome, happiness. It's a straight line. And then D is the x-intercept of BE. There's BE, and BE forms an angle beta with a negative x-axis. Okay, I see beta there. BC forms an angle. Where's BC? Okay, alpha, there's alpha, I see it, with the positive x-axis. And now ABC, that angle B is theta. So there's nothing for me to add here. All the clues they've given us, they are already on the diagram. All that's left for us is just to answer the questions. Now I'm just going to answer the questions on the right here. And what I write is what you should write tomorrow in your test. So you will write, if you're given a folio paper, you will first write question 1. Now, let me just tell you, if you're doing question 1, you should do all of it. Okay. You can only mix them if you're doing the whole question. For example, if you're doing 1.1.1, you should do all of question 1. And then if you see that question 2 is a little bit tough for you, so you want to do question 3, you should do all of question 3. Don't do this thing of saying, of doing 1.1.5 after doing question 1, you jump to question 2.3 and then you jump to 3.1. That is not allowed. You should do the whole question, right? Okay, let's just a sidebar over there. Nothing on the comment. It says determine the length AC. Now the nice thing with this topic is that it's all about the formulas. Now I forgot my formula. The other day I said to you guys, if you have to check the formula from the formula sheet, you are wasting time. You should know these formulas by head. Probably not sure what you're doing either. So I said probably, but it's not a definitive. Distance formula. I'm just going to write it once. It's the square root. I think it's x1 plus, or is it minus? I forgot. I think it's minus. I don't have it here with me. I'm just going to put minus right now. I just put on the comment section there for me. Is it a minus or a plus? I think it's a minus. And then it's squared plus y1 minus y2. Okay, if anyone knows the answer there, I'm not sure. Is it minus? Nobody knows. Or the keyboards don't know how to put a minus or a plus. Okay, so it says AC. Now I have to kind of name them. Okay, I'm going to say A, I'll call it, okay, I'll put a small XY. Please do this. And C, I'll put XY. Now, one of them can be 2, one of them can be 1. It's a minus. Thank you. Thank you. Siamo, welcome and thank you. Ransley, welcome and thank you. So let's make these ones 2, 2. Okay, they're very tiny, but you can see what's going on. Okay, so let's go quickly now. Let's put the numbers in. X1, you can see, let's X1 is minus 5, minus X2 is 7, a positive 7. Please do this exercise tomorrow. The whole thing is squared, plus y1 is 1, minus y2 is a negative 2, which is going to, a negative and a negative will change this to a positive. So I'll just put a positive, square the whole thing. Now bring out your calculator. Some of you can do this in your head. Please don't. Use the calculator and put it exactly as it looks. It's negative 5 minus 7, close it, square it, plus, open, 1 plus 2, close, square the whole thing, and the final answer is that. They said correct to 2 decimal places. Do what the question tells you. So I have to change this to decimal places, and it becomes 12.37 because 9 changes a 6 into a 7. Okay, so it's 3 7. Length is always in units, so you must write the word units. Okay, let's see who got it. 12.37. Well done, Pokemon. So you got it. Tulani, welcome. Kia, welcome. Selekane, it isn't it? Yeah, it's fine. X2 minus X1, it's the same thing. You can write that one too, Selekane. That's fine. The order doesn't matter, as Bokamoso says there. All right, let's move to the next question, which is 1.1.2 now. Okay. Stop inking this side. It's messing with my ink this side. Let's continue. The equation of the straight line BC. Okay, we're looking at BC. The first thing that we have to find is the gradient. Now, the gradient formula, change in y, which is y1 minus y2 over x1 minus x2. Okay, so for that one, we have to also substitute values so that we get the gradient between BC. Okay, let's solve for the gradient between BC. So y1 this time will be B. So I will use 1. No, that's an X. Let's be very careful. That's why we label these things. You see how easy it is to make a mistake, because I need labels. Okay. Let me just put it there. I said this will be X, that's Y. Okay, and those will be 1. Okay, coming back this side, I don't know why that keeps up. Oh, it's because I don't press the pen. Y1 is therefore 6 minus y2, which is -2. A negative and a negative makes a plus, and I put a 2 all over. X1 is 1 minus x2 is 7. Now let's put this in a calculator. Bring out your calculator like so. Start with that. 6 plus 2. Come downstairs. We have 1 minus 7. That's equals to a -4 over 3. Okay. So that is our gradient between BC. Let's try and complete now the equation so far. So far we have y is equals to -4 over 3 x plus c. Okay, we've just solved the gradients. Now we need to substitute values of x and y, which the graph passes. Okay, the line, it passes either. I can either choose C, I can also choose B. It's up to me. Let's go for B. It's 1 and 6. So that represents X, that represents Y. Where I have a Y, I substitute 6. This equals to -4 over 3. Where I have an X, I'll substitute 1 plus C. Now, in solving for C, we need to do a little bit of mathematical gymnastics. If this jumps to the other side, it becomes +4 over 3 is equals to C. Okay, Onka has an answer. Let's check. Let's bring out our calculator once more. It's going to be 6 plus put that 4, come downstairs, put a 3, and the answer is 22 over 3. That's the value of C. Now to complete my equation, I have the value of C. I'm just going to write it. Onka, well done with that. Value of C, it's y is equals to -4 over 3 x, right? And then C was plus 22 over 3. This is now the final equation. Well done, Onka. Well done, Luantle. I see your answers for the C value. Okay, so let us continue now. Swiftly moving on. Um, it says the size of ABC correct to 1 decimal. Okay, so what we're gonna do with this one, right? We guys just gonna write 1.1.3 first, and then we'll scroll up. What I want to do is I want to put the line. Okay, I'm looking for ABC, that's theta. I'm gonna put the line like this. This line is BC. Okay, B, and now it's AB. And then the line BC is gonna be like that. That's gonna, I'm making this point. C is like that. I just extended these two lines. Now we have the gradient of AB. Which gradient do we have? Let me just check. This gradient, it was for BC. This gradient, the gradient of BC is equals to -4/3. Now I'm also going to do trigonometry, so you don't have to do it. Sorry, I was just talking to my wife there. Now we need to do the gradient of AB, and the gradient of AB is going to be change in y. Let's make b x1. X1 will be 1 minus, and then that's a -5. Minus and a minus makes a +5 all over y. Hold up. Who said the gradient we start with? Guys, it's my wife who disturbed me. So it's changing y over changing x. So we should start with 6 minus 1. And then at the bottom, x is 1 plus 5. Yes. Now we're on the right track now. Concentrating. Fraction sign, 6 minus 1. Come downstairs, 1 plus 5. And then we get 6/5. 5/6. What's going on, guys? Did anyone else get 5/6? Am I the only one? So that's the gradient here of AB. What do we do with the gradient? Now, remember, when it comes to the gradient, another formula of a gradient is tan. Let's start with ABC because we had the answer first. Now, that's the tan of alpha is equals to -4/3. Now we need to, it's correct, sir. Thank you, Pokamoso, for confirming that. We need to solve for theta. So I mean alpha. So we'll say alpha is equals to, now remember, there are many methods of doing this, but my preferred method is just to say, in grade 12, the sign is just telling you which quadrant are we working with. Okay, so 10 is negative in, if you remember cast, it is negative in this quadrant and also negative in that quadrant. But because we're looking for an angle of inclination, an angle of inclination is always between 0 and 180. So we are working with this quadrant. What I'm solving for now is what we call it's a placement angle. I forgot the name of it that we call it. It's an angle. It's a reference angle. Yes, it's a reference angle. Okay, so it's a reference angle. We will just say, so since we're solving for the reference angle, it's the reference angle. Okay, the reference angle will then be arc 10, which is 10, and then you put 4/3 in the bracket. Now don't use the sign again. That sign is just telling you the quadrant, but once you get to arc 10 or arc what, always take it as positive. Okay, so this one is 4, come downstairs, you put a 3, go to the side, close it, and then what do we get? 53. 53.13 is our reference angle. Okay, so now we are looking for the angle in the second quadrant, and that's the actual angle of alpha, and it's always 180 minus the reference angle. Okay, so it's 180 minus 53.13. You can also see the angle here is an obtuse angle. We solved for an acute angle. Answer is 87. Well, let's see. I doubt it is though, Bokamoso. Minus 53.13. That's gonna be equals to 126.87. This is an angle, so it's in degrees. This is the angle of alpha. There we go. We have just solved. Oh, that's your final answer. Okay, I don't know. We've just solved the angle of alpha, which is actually, if I am to complete this, remember the angle of inclination is always from a line that is horizontal. So we just solved this angle. Okay. Now let's go and solve AB. So for AB, that's the angle of beta now. It's still going to be 10. This time it's beta is equals to the, which is the gradient, which is 5/6. 5/6. We got 5/6 there. 5/6. It's positive. Okay, so that's fine. So beta is just going to be arc 10, 5/6. That's what we put in the calculator. Bring back our calculator. And then we go shift 10. There we'll put 5, come downstairs, put a 6, go to the side. There we go. 39.8. I'm going to say 81. 39.81 degrees. Now what we just solved is this angle here. Let me make it green. This angle here. But we are really just looking for that angle there. So I take the blue, the blue one, and subtract the green one to get my final answer. And whatever answer I get there is vertically opposite to the theta I'm looking for. Okay, so I'm gonna say 126. 126. Remember, now we're solving for theta. 0.87 minus 39.81. Now let's bring out our calculator. Let's see what we get. It's 126.87 minus 39.81, and that's going to be equals to 87.06. 87.06 degrees. Let's see. Ha! Bokamoso, you are so quick. Well done. Tiamo, 126.87 question mark. Why is that a question mark? You don't know how we got it. Like I said, we are working with the answer from the second quadrant. In the second quadrant, you use the reference angle, and it's 180. The identity we use there is 180 minus the reference angle. Okay, you do that. And also you see the reference angle is an acute angle, but if you look at the line here, it's an obtuse angle, which means you really have to subtract it from 180 to get the correct answer. Okay, let's not spend too much time on this question. Let's move on. These are the marks you should be picking up tomorrow. Oh, it said correct to 1 decimal place. Read the question very carefully. So then this becomes 87.1, I guess, degrees. Let's see what the calculator gave. Yeah, 87.1 degrees. This is now your final answer. Make sure to read the question carefully and answer what's been asked. It says now in 1.1.4, the coordinates of P, the midpoint. Okay, so P is a midpoint and it's going to be given by x1 plus x2 over 2. That's for the x coordinate. For the y coordinate, over 2. Now, this is between A and B, so I exclusively look at the values there. X1 being A, so it's going to be minus 5 plus x2 being on B, so that's going to be 1 over 2. This side, y1 being on A, which is 1, y2 being on B, which is 6 over 2. Now let's bring out the calculator. Fraction sign, negative 5 plus 1. I know you can do it in your head, but please don't. Is equals to, so now P, first one is negative 2. And then this one, 1 plus 6. Come downstairs, put it to 7 over 2. 7 over 2. Is that correct? Can anybody else confirm that? Looks good to me. 7 over 2. Maybe if I'm to convert it to a decimal, 3.5. It's fine. I'll leave it like that. Let's go to 1.1.5. Scroll down. Yes, sir, it's correct. Thank you. Thank you, Neo. Thank you, Luandle. I see you. I see you guys. You're working. That's good. Let's go to 1.1.5. The equation of the line parallel to AC. I see AC, so we'll need a gradient. We'll need the gradient of AC. Passing through the point minus 1 and 3. Okay, that's cool. Let's get the gradient first of AC. Oh my goodness, yes, it's technology sometimes. So, like I said, the gradient of AC. Gradient of AC, let's go. We're gonna say A will represent 1. So y1, the change in y is 1 minus y2, which is minus 2. Minus and a minus makes a positive, so that it's going to be plus 2. And then looking at the x values now, minus 5 minus 7. Okay, let's put that in a calculator. Don't play with your marks. Don't do this in your head. Use a calculator, please. Don't leave anything to chance. I know under exam stress, very easy to make a mistake. So it's a negative 1 over 4. That's the gradient. So let's start completing our equation. It's y is equals to negative 1 over 4x plus c. Now they have given us a point where it's passing at negative 1. and a positive 3, where negative 1 represents x, and that's y. Where there's a y, I substitute 3, and where there is an x, I will substitute negative 1 plus c. If I take this, doing some mathematical gymnastics to the other side, it becomes 3 minus 1 over 4. I think so. Is that right? Somebody confirm. This is positive. A minus makes it positive. So when it goes to the other side, it becomes negative. Maria says yes. Welcome, Maria. 3 minus 1. Come downstairs, put in a 4. Put it exactly as it looks there. So it's 11 over 4 is the value of C. So when we complete our equation now, it becomes y is equals to, what was the gradient? Negative 1 over 4 x plus 11 over 4. Well, looks good to me. That's how you do these equation questions. So this is question 1 tomorrow. Please make sure you get all these marks. These questions, you are definitely going to see them tomorrow. So just make sure, practice. Okay, let's go for question 2 now. Question 2 says, in the diagram below, P is the center. Oh, wow. And they give us the point of the center of the circle that has y axis as a tangent. Okay, so if it's a tangent, that means the circle touches the y-axis actually at one point, right there. A, B are the x-intercepts at P. Okay, thank you. First of all, it says, what is the radius? What is the radius? How do you think we're going to solve this? So to solve the radius, Bokamoso 13. Well done, Bokamoso. You got the answer correct there. Very well done, Bokamoso. I see you. I see you. You're doing well. So the radius, this question, if you look at the number of marks, it's just 1 mark. That means there's probably no solving is to be done. But remember this information that they gave us there, it's a tangent, the y-axis, which means, using a red pen, from the center to the y-axis, that's where we get our radius. And we know that this point represents, the 3 represents the x, the -2 represents the y, which means from here to here, it is 3 units. And then from there to up there, no, to, it doesn't reach the circumference. To there is 2 units. Okay, well, it's -2. So it is 3 there and -2 there. Cool. These are the points. All right, so that's what it's like. So on the x-axis, we have a 3, same as there. And then on the y-axis, we have -2, which is just 2 units. That's cool. So then to solve our question, I'm going to come back this side and then say, oh, we're on question 2 now. We are now on question 2. And then we are saying the first question that asked us is 2.1.1. The radius is just simply equals to 3. We're not solving anything. There we go. Did anybody get it? Let's see. Okay. 2.1.2, the equation of the circle. Now, to finish, it's also a 1 mark question, which means there's nothing to solve. Remember the equation of the circle, starting with the x, which number is on the x-axis. If you look at the number on the x-axis, it is 3. Okay, there we go. But remember, when you're inside the bracket, you always change the sign. So it's a positive 3 here, which means here it must become negative 3. Close and square, and then you put a plus, and then on the y, which number is with y? It's negative 2. Change the sign, so this one becomes positive 2. Close and square, it's equals to, the radius is 3, so you must say 3 square. Let's just square every single thing. Everything is in terms of square. Okay, let's move on. Calculate the distance AB. This one is a little bit tricky. Okay, so AB, what did they say about AB? AB are the x-intercepts. How do we solve x-intercepts? We always say let y equals to 0. Oh, it wasn't 2, it's just 2.2, my bad. 2.2. Make sure you also do your numbering very well tomorrow, because if teachers don't know what number you're working with, then they'll just mark it wrong. Let y equals to 0. That's the only way to solve x-intercepts. You have, say, I don't understand the way you found the radius. Oh, the radius. Remember, from the center to the, what a radius is. It's a line from the center to the circumference. And they told us that this particular circle touches the y-axis at a particular point. Now, if we draw a line from that particular point to the center, that line is actually a horizontal line, and the horizontal line is horizontal just like the x-axis is horizontal, and the circumference to the center, that horizontal line is 3 units, which means that the radius is therefore 3 units. Hope that helps. Let's continue with let y equals to 0. So then it means I have x minus 3. Now I like to open 2 brackets. Okay, the square means open 2 brackets. We have to multiply it out. Plus 0, where there's a y, I substitute 0 plus 2 is equals to 3 squared. Okay, let's multiply it out. It becomes x times x is just x squared. X times negative 3, negative 3x, negative 3 times x, negative 3x. Negative 3 times negative 3 is a positive 9. Okay, this one is squared. Now coming to this bracket, 0 plus 2 is 0. 0 plus 2 is 2. And then 2 squared is actually 4. So it's plus 4. If I bring this to the other side, doing the gymnastics, it becomes minus, what is 3 squared? It's 9. Okay, so this is equals to 0. What are we doing? Oh, we're solving for the x-intercepts. Then it's x squared minus 3 is minus 6x. 9 minus 9 is 0 plus 4. Okay, there we go. Now, if you remember, paper 1, I said we must use the quadratic equation for this one to solve for x. So x is going to be minus b plus or minus, you have to write it at least once, b squared minus 4ac all over 2a, and then we substitute minus b. So that's a, that's b, and that's c. So minus b is minus negative 6 plus or minus square root b squared is negative 6 squared minus 4 times a, which is just 1, and then c is 4. Close that. Come downstairs, put 2, and the value of a is just 1. Now put this in a calculator straight away to get your final answer. So start with the fraction, minus, open it, negative 6, close, starting with the plus, square root sign, open, negative 6, close, and then square it. And then you say minus, open, 4, close. That wasn't necessary, but anyway, open. I'm just going to put it 4. I'm going to skip that 1 because anything multiplied by 1 still that same thing. Okay, so we got that. I'll change it into a decimal. So then x is equals to 5.23. Let me change it to 2 decimals. 2, 3 comes to 4. Or we go back, change the positive into a negative. That's cool. That's that. Actually, the third form one is even more correct than this decimal one. 0.76. I can do this, or I can leave them in third form. Usually they do specify, but this time they didn't, so I'm just going to choose whatever I like. I like decimals, so there we go. But the more accurate one is the third one, of course. I see your comments. You calculated the wrong digits. Distance, sir. What am I looking for? Oh, I thought oh, no, I didn't calculate the wrong distance. So all I'm saying, okay, so what that means is that this is not the final answer. It means we haven't actually answered the question. These are my intercepts. So it's end. That means A is the one on the left, which is 0.76 units. And then B is the one on the right, which is 5.24 units. Okay. A is 1. How did you get A is 1? No, A is not 1. It's definitely not 1. Anyway, so that's the value of B. That's the value of A. Then the distance AB is therefore 5.24 minus 0.76. That means from the origin to A, that is 0.76 units. From the origin to B, that's 5.24 units. Subtract the both to get the distance between A and B. Now bring out your calculator. I put 4 in the calculator. Huh? I put 4. What's Kia talking about? Yeah. The value of C is 4. It's correct. Check my formula here. A, B, C. Kia. It's 4 and 2. I don't know what you did. But anyway, my working is correct. So let's see what the final answer is. 5.24 minus 0.76 is equals to 4.48 as my final answer. So the distance between A and B is 4.48. This is definitely the correct answer, Kia. Watch out for your mistakes. I don't know what you did, but it's not 4 and 2. This is the correct answer. You follow, just because it's decimals, it doesn't mean it's wrong. It doesn't all, we don't always have to be perfect. What you were telling me, Kia, is that you are a perfectionist. You want your numbers always perfect. Unfortunately, that's not always the case. Sometimes they will not be perfect. Okay, let's move to 2.3 now. It says another circle with that equation. Determine the radius and the coordinates of the center of the circle. Wow. So for this one, we have to complete the square. Let me just write it first. It's x squared plus 2x plus y squared minus 8y minus 8 is equals to 0. Okay, now to complete the square, I'm going to leave this as x squared plus 2x plus, now I'm going to open a big bracket, put the coefficient of x, divide it by 2, close the bracket and square the whole thing. And what I did here, I need to do it also on the other side of the equal sign. This number here, I'll put it exactly as it is, 2 over 2 over squared. Now I'm going to write this y squared as well, y squared minus 8y plus, open a bracket. I don't have enough space there, so what I'll do is Technologia. What is it doing to me? Okay, I will put it, I'm gonna write it below. This one, I take the coefficient of y, which is 8, divided by 2, and then square the whole thing. What I do on one side, I must do also on the other. Squared. And then there is also this number here, which is minus 8. I will take it to the other side also of the equal sign. I want to take numbers to the other side, and it becomes plus 8. Okay, it just becomes plus 8. Now, to complete the square, open the bracket. From here, everyone is working. From here, I just want the x. From this second one, I just want the sign. From this third one, I just want what's inside the bracket, not the whole thing, just what's inside the bracket. 2 over 2 gives me 1. Close it, square. Plus, from this fourth one, I just want 1, y. From this fifth one, I just want the sign. It is negative. And then from this one, this last one here, just want what's inside the bracket, which is 8 over 2. 8 over 2 is a 4. Close the whole thing, square it is equals to. Now I need to put these numbers in a calculator. Okay, so the first one is, I'm just going to say 1 because I know 2 over 2 is 1. 1 squared is 1 plus 8 over 2 is 4, right? So 4 squared is 16 plus this final 8. And that's 25. 25. Okay, let's go back to the question. What did it want? First of all, it wants the radius. So the radius is just 25, the square root of 25. Remember, everything is squared here. Every single thing is squared. So this number is a square number. So the actual radius is just 5. Cool. And then they wanted the coordinates of the center. Okay, so the coordinates of the center are just, let me write the word center. the coordinates of the center, you just look what's inside the bracket. Remember to always change the sign. So with the x, the number associated with the x is -1. The number associated with the y is now a +4. So that's the center. How we doing, guys? How we doing? I see no comments. All right, let's move on then to the next question, which is 2.4. It says, will the two circles intersect? Clearly motivate your answer by means of a calculation. So remember, just to put this into perspective, we are now on 2.4. The one circle has a radius of, we solved it, I think it was 3. Yeah, there it is, 3. The one circle has a radius of 3. And then the other circle, let's make it blue. This circle that we just solved now, it has a radius of 5. So when we sum the radii, we get 3 plus 5, which is just equals to 8. Okay, we know the radius now. Now we need the sum of the distance between these, the actual distance between the centers. Remember, this one had a center of, I'm just going to put it there. This black one had a center of 3 and -2. And then this blue one has a center of -1 and 4. So what we have to do is solve the distance between these two centers. Okay, I hope you get me here. Kia, I hope you get me, Kia. Okay, we're gonna compare the two answers. Now let's get the distance. I'm not gonna write the whole word. It's the square root of x1. Let's make the black one 1. So it's 3 minus x2, which is -1, and negative and a negative makes a positive, so that it becomes +1 squared plus, now let's look at the y values. It's -2 and minus, this one is just a +4 squared. All of this is under a square root. All right, we need a calculator for this one. Bring out your calculator. Square root sign, open the brackets. 3 plus 1 is actually 4, so I'm not going to put the whole thing. It's 4 squared plus, this one I have to put it, -2 minus 4, close and square the whole thing. And let's change it to a decimal so it looks better. So the actual distance between the two, 7.21. Now let's think about this. Let's think about it. Okay, so like I was saying, the sum of the radii is 8, right? But the actual distance between these two centers is 7.21. If the actual distance between the two of them is less than the sum of the radii, that means they will definitely touch, because it means, actually, if I'm just to redraw this, okay, if I'm to, well, let me just extend it. This circle, it means it actually goes a little bit inside. such that the actual distance between here and there is 7.21. That's the actual distance. But when you look at the radii, the radii is still 5 and the other one is still 3. Hope that makes sense. Onka, I don't know why you're putting your hand up and laughing. I don't know what sign that means. But anyway, let's move on. That's how we're done now with, it took an entire hour to do analytical. I was moving very slow. You should be much faster tomorrow because you got 3 hours and it's too much time to spend on analytical an hour. All right, let's go for question 2 now. Question 3. It says if cos 22 is equals to P. Okay, so cos 22 is equals to P. Determine the following in terms of P. Whenever you get these questions, always remember to divide this by 1 so that when you complete your triangle, let's complete the triangle here. And I'll put P here. I know cos is equals to the adjacent over hypotenuse. Okay, so the adjacent is down here. That's the P. Adjacent to P is down here, which is, no, why did I put P inside there? It's actually the cos of 22. So the angle is 22 and then P is a side. It's like this. It's 22. P is there because that's adjacent and the hypotenuse is 1. And then this side, we are going to have 1 squared, which is just 1, minus P squared, completing Pythagoras. Remember, we have a right-hand angle there. Lwandle says, so, sir, if the sum of the radii is greater than the actual distance between the circle centers, it means they intersect. Yes. Didn't I conclude? Oh, yes, I forgot to conclude there. Thank you, Lwandle. So our final conclusion here, let's see the question. Will the two circles intersect? Then the final, therefore, yes, comma, they will definitely intersect. They will intersect. Most definitely. Why are they intersecting? Because the distance is less than the sum of the radii. Cool. Thank you, Lwandle. Okay, so moving on swiftly. First question is 3.1.1. I like black. Cos 158. Now we have to use reduction formulae. So we can rewrite actually 158 as 180. We'll do the check now. Minus 22, because everything has to be in terms of 22. All right. And let's do the check. 180 minus 22. That gives us 158. So that's cool. Now, this thing in the bracket, it's just telling us which quadrant we are working with. Okay. So remember, it's 180 here. So it's 180 minus 22, which is in this quadrant. And according to CAST, cos is negative there. So this becomes negative cos 22, which means our final answer then is negative cos 22 is just P. So there we go, P over 1, which is just P. That's our final answer. Let's move on. Now we are on 3. Oh, let me see. Did anybody get it? Nobody. Cool. 3.1.2. We've got sine 112. Now the trick is, how do we manipulate numbers in order to get 112? I know that it's close to 90, so if I say 90 plus 22, let's check it. Let's check it out. Does 90 plus 22 give us? So you always look at what's the closest special number. So it does give us 122. Now this sine, this is the second quadrant where sine is positive, but because it's a co-ratio, because of this 90, sine changes to cos 22. And cos 22 is just equals to P. That's it. Nothing more, nothing less. Let's move on. 3.1.3. Did anybody get it? Let's see. No, nobody got it. Oh, they did. Kia got it. Well done, Kia. You're redeeming yourself. A CC Paul, well done. I see you got the right answer. Kia, again, you got the right answer. Well done, guys. Now let's look at this very difficult one, sine 38. Now, if I look at this number 38, it's not close to any special number that I know in combination with 22. So what it can do is we can then look at the special angle numbers, which is now 30 and 60. Remember, actually, when we think of special numbers, we should think of 0, 30, 60, 45, 90, 180, all those 270 numbers. So let's see. How can I get 38 using 22? Sine. What if I say, let's take out our calculator. What if I say 60 minus 22? Does that give me 38? It does. So I'm going to say 60 minus 22. There we go. Now this is a grade 12 identity. What do we call this kind of identity? Compound angles. This becomes sine, I forgot, sine 60 cos 22. Is it a minus or plus? It's a minus. Cos 60 sine 22. Okay, that's what we do. I hope you remember this identity. It's also in your formula sheet. You can check it out there. Sine 60 is a special angle. If you're not sure of what sine 60 is, just use your calculator. Just say sine 60. But take the fraction part of it. Otherwise, yeah, it's square root of 3 over 2. Cos 22 is just P minus cos 60. Let's use the calculator as well. But take the fraction side. Cos 60. Let's close it. It's a half. It's a half. And what's sine 22? Sine 22. Okay, come back here. Come back here. Let's come back here. Sine 22. How are we going to get sine 22? How we need sine 22? Okay, there are a few ways you can get sine 22. If you go back to the easiest way, it's just to look at your, what do you call this? Your diagram, your triangle that you created. Sine is given by opposite over hypotenuse. If you look at the opposite, it is this. The hypotenuse is 1. So we just write that, which is a square root of 1 minus P squared. Okay, there we go. Can we simplify this? I don't think so. So we're just going to leave the answer like that. It's good enough for me. This should be good enough for your examiner. Your teacher should be good enough for yourself. All right. Now we are looking at the general solution. 3.2. It says determine the general solution of 4 plus 7 cos theta plus cos 2 theta is equals to 0. Okay, so for this one, I have to expand it first. And to expand it, Asisipo, what's it? Square root of p. Yes, you are very much correct, Asisipo. I actually don't know how you wrote a square number in this chat. That's amazing, eh? It's incredible. Okay. So anyway, I can't simplify a 4, so it will remain as a 4 plus 7 cos theta. I can't simplify that. I can't expand it. This one I can expand. Remember, cos 2 theta has 3 answers. You choose one, the one that is going to help you. I'm going to choose the one that has a cos. Okay, and the one that has a cos, if I check, the one that has a cos is actually 2 cos squared theta minus 1. Okay, now I'm going to rearrange this so that it looks a little bit better. It looks like a quadratic. 2 cos squared theta plus 7 cos theta. This number minus 1 plus 4, or 4 minus 1 is just 3. Is equals to 0. Now this is a quadratic equation. Let's just pretend, let's play pretend now, or use the K method. Let's pretend that this is x. So this becomes x. Cos theta is x, so this one would be x squared. That 2 remains, that plus remains, that 7 remains, that plus remains, that 3 remains. This is now my value of A, that's my value of B, and that's my value of C. So using the quadratic equation, we're going to have minus, open bracket, B was B, it's 7. Plus or minus the square root of 7 squared minus 4a is 2, and c is 3. Cool. All over 2 times a, which is 2. Now let's put this in a calculator. Let's see what it gives me. So put a negative, open the bracket, 7, close it. Start with your square root sign. Before you do that, put a plus. Let's start with the plus. Put a square root sign. It's 7 squared minus 4. Open the bracket. Put in a 2. Close it. Open it again. Put in a 3. Close it. Come downstairs. 2 times 2 is 4. I'm just going to put 4. It's my calculator. So x is equals to negative a half, or x will then be equals to, let's go back, let's change this plus into a minus, equals to negative 3. Now remember, x is actually not x. X is cos theta. So this one becomes cos theta is equals to negative a half, or cos theta is equals to negative 3. This one is not possible, not available. Cos can never be equals to negative 3. Remember the graph of cos, it actually oscillates between negative 1 if you remember the amplitude. That's why you need to learn about amplitude. Okay, it oscillates between here. So -3 is way outside there. The graph doesn't exist there, does it? But at -half, definitely -half is right here. So all these answers are correct. -1/2 here. That's what it means. Okay, so but we're looking for a general solution. So let's start with our reference angle. Did anyone get the answer? Very good, Lwanze. So here we're gonna say for our reference angle, I'm just gonna call it a reference angle. It's going to be cos, and then I take, remember the signs just give us which quadrant we're working with. Under cast, okay, cos is negative in this quadrant and that one. So those are the two quadrants we're working with. Okay, so -1/2, we'll put a half, never put negative number inside there because we've already used the negative sign on determining the quadrants we are working with. So the number inside the arc cos will always be positive. 0.5 is a half, so we get 60. That's the reference angle. Now we are working with which quadrants? The second quadrant. So in the second quadrant, and we're also working with the third quadrant. In the second quadrant, theta is equals to 180. Second quadrant, remember 180 is right there. Second quadrant is minus the reference. And then we are going to say plus K360. Repeats itself every 360. So that point becomes that point. 360 between there and there. Okay, so what's 180 minus 60? I can do it in my head, but I'm under exam stress. I don't want to think too much. Got better things to think about than 180 minus 60. It's 120 plus K360. Now, this is just on the second quadrant. We have to do the same now for the third quadrant, where it's also third, it's theta plus, no. Am I getting tired? I'm not sure. It's 180 plus the reference, which is 60, plus K360. Very good. Oh, Asisipo is on a roll. Let me take Asisipo's answer here. I believe you, Asisipo, when you say 180 plus 60 is 240. I will take your answer. Very good. Very good. Now, these are two answers for general solution over there. Thank you so much, Asisipo. Let's move on now to question 4. Question 4 says, in the diagram, P is the point C and that such that OP is 5 units. 5 units. We are now on question number 4. I prefer that you actually complete this, okay, yourself. So that, first of all, we are on the fourth quadrant. And it's like this. That's the point P. They tell us OP, okay, is 5 units. So it's 5. And then C is from there. It represents the X. So it's from there. C is here. And then this one is, I'm talking of units now. I'm not considering the signs, units. Of course, this is positive. That's also, it's on the negative sign. That's cool. So what we're going to do now, calculate the numeric value of C. You can see that this is a right angle triangle. So we're going to use Pythagoras. we're going to say, remember hypotenuse is the one that's opposite the right angle. So the hypotenuse is 5. So we're going to say c squared plus the square root of 21 squared is equals to 5 squared. Okay, so this becomes c squared plus 21 is equals to, what's 5 squared? 5 squared must be 25, right? 25. Now c squared is equals to 25 minus 21, which is 4. And then if I square root both sides, c is either plus or minus 2. You have to choose one. Okay, c is, well, let's choose the positive one. It's okay. So we're just gonna say c is equals to 2. Very good. So now we've got complete answers. 4.1.2 says determine without the use of a calculator the numeric values of the following. First one is cos theta. Now remember, our theta is over here. Cos theta, cos is equals to, we're working with units, right? Is equals to, let me write it down. Cos theta is equals to the adjacent of a hypotenuse. So the adjacent, if we look at our triangle here, is 2. Anybody get it? The adjacent is 2 over the hypotenuse is 5. Okay, we're looking at our triangle. It's 2 over 5. Good. This is for A. And then B, it's tan theta plus sine squared theta. Don't worry, we're just gonna look at our triangle upstairs. Start with 10. Oh, by the way, the reason my answer is positive is because cos is positive on the fourth quadrant. Remember, our cast diagram is positive, so our answer has to be positive. But 10 now, 10 is negative. So first of all, my answer must be negative because I'm using units. I'm not actually using the signs on the diagram, on the Cartesian. So it is, if I think of cos using SOHCAHTOA, it's opposite, and the opposite is square root of 21. Remember, so square root of 21, it must be negative, over the opposite adjacent is 2. There we go. Plus sine squared theta. Now I'm going to put it in the brackets because it's squared. And anything squared is always going to be positive, but I want to put the right one first. First of all, in the fourth quadrant, sine is negative, so this must be negative inside the bracket. And then it's opposite over hypotenuse, SOHCAHTOA. So opposite is square root of 21 all over the hypotenuse, which is 5. Okay, we've got a strange number this time. And the whole thing has to be squared, right? Oh, what happened here? And the whole thing has to be squared because you can see we're working with a square here. Now bring out your calculator. I assure you your calculator is well within its rights to do this sum. 21, come downstairs, put a 2, go to the side, a plus, open again, negative square root of 21, come downstairs, put in a, not a 2, put in a 5, Go to the side, close it, and square it. Then the final, ooh, that is such a strange number over there. Let's see what you guys got. Okay. But anyway, this is it. That's how I guess that's the correct answer. If I change it to a decimal, just negative 1.45. Did they say anything about what form we should leave it in? Numerical value of, well, they didn't say, so I prefer decimal. It's much shorter. Okay, let's go now for the C. Okay, are you guys okay? I'm writing tomorrow paper 2, and I'm relieved to see your work, sir. I have been struggling. Asisipo, you are not struggling. You've been giving me correct answers. What are you talking about? You're doing very well. Okay, let's look at sine 2 theta. Now remember, we have to expand sine 2 theta. This is what we call the double angle. It becomes 2 sine theta cos theta. Now you have to know this by head. You don't have to, go to the back of the book. So we put it 2 sine theta. Remember, we're working with the fourth quadrant. In the fourth quadrant, sine is actually negative. Now we can look at the numbers. It's opposite over hypotenuse. The opposite is the square root of 21 over 5. And now cos is positive. Cos is 2 over 5. Cos is 2 over 5. 2 over 5. Okay, so let's just put this once in a calculator to get a final answer. It's 2. Put it exactly as it looks. We've got negative square root 21. Come downstairs, put a 5. Go to the side, close it, open another one. Fraction 2. Come downstairs, put a 5, and then close it. What do we get? A third. Let's change it to a decimal. They did not specify, even though the third is much cuter than the decimal, but I mean, look at it. The decimal is much simpler. The third is correct. It's just, I mean, it's the way it looks. I don't like the way it looks. It looks weird. Okay, let's see any comments. Nothing. That means we can move on. Oh, Luanze got it right. Very good. You too. That's simple. You got it right. Okay, let's move on. We are now on 4.2. Simplify sine x minus 180 dot tan x dot cos 690. This is all over cos squared x minus 19. Okay, so remember we're dealing with quadrants here. So I'm going to do this exercise. Remember, a positive direction is anti-clockwise. So we want to know which quadrant is this. We go x, it's in this quadrant, minus 180. We turn around then and we minus 180. We are now on the third quadrant. On the third quadrant, is sine positive or negative? Let's go cast. Then you need to know your cast. So it's negative. So then this we can rewrite as negative sine x. 10x, we can just rewrite it, nothing to do there. Cos 690, bring out your calculator, subtract a revolution first, 690, because the revolution is 360. it's 330. So it's like 330 is now on the fourth quadrant, and 330 we can rewrite as 360 minus 30. So yeah, so this is just cos 30 all over cos squared x minus 90. So we go x minus 90. Okay, so first of all, you must remember that whenever you see 90, we're talking corratios. And according to corratios, a cos changes to a sine squared x. Okay. And since its cos is actually positive in the fourth quadrant, because that's where we are, we went x, it brought us on the first quadrant. We said minus 90, it just brought us to the third quadrant. I mean, on the fourth quadrant. And on the fourth quadrant, cos is positive. And then the 90 changes a cos to a sine. Now we kind of have to simplify further. Whenever you see a 10, 10 is the next thing that you always have to change. So minus sine x stays, 10 becomes sine x over cos x. Soka Toa. And then this one, cos 30, I want to deal with it immediately. It's a special angle 30. So we can always change that one. And then it becomes square root of 3 over 2. All right, at the bottom here, this is the big one, the sine squared x. All right, let's see what cancels with what. Now we have to do the cancellations. So this sine x cancels with one of these. And then I'm left with, let me rewrite this, square root of 3 over 2. And then I'm left with what's in the bracket, which is sine x over cos x. Now, if I divide this whole thing by a sine x, that's like, I can put it, that's like dividing. Okay, so this sine x is actually, let me just put it because I want to do one thing at a time. Sine x. One of them canceled that one on top. And then the second one canceled that one. So this one would cancel that one. And then my final answer, I'll be left with square root of 3 over 2. And then, okay, the cos is at the bottom, so I'll put the cos x right there. That's my final answer right there. Doesn't look right, but it's very correct. And there was a negative, that negative that I have to continue with. So if I'm gonna write this in a much more cuter way, it'll be negative square root of 3 all over 2 cos x. There we go. Now it looks cute. Look at that. It looks much better than that. Okay. We're good. What about the negative sign? Onka is reminding me of the negative sign. There we go, Onka. You have it right there. Let's move on now to question 5. Oh my gosh, we're still on trig. In the diagram below, PQ, there's PQ, is a vertical mast. RS are 2 points in the same plane. You need to be able to visualize this on the same horizontal plane. So these, just to highlight, thickness is too thick. Just to highlight, this is on the floor, right? If you can imagine that, it's the triangle that's on the floor, this one. Okay, and then this one is standing upright. Two triangles connected by QS. Okay, same horizontal plane, mass Q. Okay, R is alpha, there it is. S is beta, and then they give us SR, and they give us SQ. The angle of elevation of P from the bottom to the top is Q, is theta. There it is. So they gave us all of them. They gave us everything that we need to succeed. Now let's read the question. We are now in question, I don't know, what question is this? Let's check it out. 5.1. Okay. So on question 5. We are now on question 5. Question 5. 5.1. It says express PQ in terms of QR. PQ. Now, if you look at PQ in terms of QR, and a trigonometric ratio of theta. Now, what we have here, just to isolate that triangle, we have P, we have Q, and we have R, and we have a right angle, and we have a theta there. We can say opposite R is the opposite. So, and then QR is, in terms of theta, it's the adjacent. So what combines opposite and adjacent is 10. So 10 theta is equals to the opposite, which is PQ, over the adjacent, which is QR. Now PQ, which is cross multiply, and then it becomes QR 10 theta is equals to PQ. That's it. I feel like this was a 1 mark question. Yep, it was 1 mark. Look at that. Just 1 mark for all of that. But let me rewrite it nicely for you so that it looks a little bit cute. So it's PQ is equals to QR 10 theta. Okay, let's go for 5.2. Let me check your Bokamuso. Can you write the number alone and cos X on the side, or it must be under there? Or you can separate it, Bokamuso. It's up to you. It's up to you. I think it must be under cos you. Okay, I see what you're saying, Onka. Yeah. It looks cuter the way I did it, the way I wrote it. But you can write it like that too, Bokamuso. All right, let's go now for 5.2. It says show that PQ is equals to that. Ooh. They gave us something looking a little bit weird now. Okay, but if you look at that, we're just rewriting PQ in terms of beta and theta now. Okay, so for this question, we will use the sine rule. You can also use the cos. I mean, if it works out, it works out. Let's use the sine rule for the purposes of this one. So I need to rewrite QR in terms of these other angles and sides. So what I'll do is I will say QR over sine. Remember, I'm doing the sine drill. The angle opposite QR is beta, so it's sine beta is equals to, I need one angle that has been actually given to me. I can use X. Okay, is equals to X, that's one side, over sine opposite X is the angle alpha. So QR can be rewritten as, if I do the gymnastics, X times sine beta all over sine alpha. Okay, so I just rewrote that. Now to write PQ now is equals to QR, but QR we just solved it to be X sine beta all over sine alpha. That's QR, and then attached to that we have tan theta. Okay, does it look the same as what we've been given there? Absolutely does. It's just a proving question, this one. It's nothing much to solving. Okay, so 5.3 now. 5.3 says if beta is equals to 60 degrees, show that the area of QSR is that. Ooh, they're basically saying solve the area of this QSR. Okay, let's solve the area. The area, if I remember correctly, is half base. So we're gonna use the QS, which is X times the other one, which the other side, which is let me put it in brackets, 8 minus 2x, and then sine, it must be the included angle. Remember what an included angle is. An included angle is an angle between the two sides that you just used. So if I'm using this side of X and this side, I can only use one angle. The included angle is beta. Okay, so I'm gonna put the angle of beta. Yeah, I hope we're good. What are you saying in the comments there? Ivelapi 10 theta. Which question? Ivelapi. No. It's in the, remember I'm rewriting PQ. So 10 theta was already there. It was definitely already there. Okay. So let's continue. I'm going to rewrite this. 8 minus 2x times sine. Now they told us beta is 60 in the question, so I'm just gonna substitute 60, and then we have a half x, 8 minus 2x, right? Close that. 60 is a special angle, so just put it in a calculator quickly. Sine 60, close, it is square root of 3 over 2. Now you have to continue with gymnastics. It's kind of like you have to multiply everything inside. So a half times 8, let's start with the left one. A half times 8 is, I don't know, what's a half times 8? It's 4, isn't it? And then there's this x. And then I have a negative. A half times negative 2 is actually -1. And then x times x, what I'm doing, if you're not sure what I'm doing, I'm just multiplying this in like that. That gives me a half, that's 1, and then that gives me x squared. So I have x squared now. And then outside, I still have a square root of 3 over 2. Let's continue to multiply these out. Square root of 3. Now, if you're not sure what I'm about to do, I'm about to do that. Okay. So square root of 3 over 2 times 4, that will give me square root of 3. See what happens when you're using your head. Sometimes you are actually a bit slower than you would be if I was using a calculator. Okay, but I know what the answer is now. What's going on? Wrap this thing. I don't want it. Oh my gosh. Okay, anyway, this one, if you put it in a calculator, 4 over 2 will give me 2, and then I'm left with square root of 3. And then that x is just staying on its own. And then minus square root of 3. Well, this one, there's nothing much I can do. It remains a square root of 3 over 2 times x squared. That's it. Does it look like the question? Yeah, boy, it does. So we're all good. This is our final answer anyway. Determine the value of x for which will be a maximum. Ooh, this question requires you to think a little bit. Okay. So maximum we know that in order to get a maximum, it means the graph, this graph here, is actually like this. Maximum is over there. So which is, you know, solving the turning point. Okay, and to solve the turning point, the x value of a turning point is actually equals to minus b over 2a, if you remember this method, where this represents a and that's b, because those are the coefficients attached to those values there, to those Bazalwan. The pressure is getting worse. So what do you mean? We are moving, we are cruising very nicely here. X is equals to minus the value of b is 2 square root of 3 over the 2, and then the value of a is a negative square root of 3 over 2. So this one I can simplify, but let me just use a calculator. -2, and then square root of 3, and then we go downstairs, we put a 2, open a bracket, put another fraction there, negative square root of 3, come downstairs, put in a 2, go to the side, close this. Looks exactly the same. And my final answer is just 2. Okay, so x is just 2. That's it for 5.4. Quadratic equation. Yeah, boy, it's a quadratic equation. Very good, Kia. You got the answer. And the answer is 2. You are very correct. That's how we do it. So whenever you see these words, maximum, minimum, you must know you're dealing with the quadratic there. Okay. And it's only a maximum if the graph is a negative graph, and a is negative, so that's correct. And it's a minimum if the graph is positive. We're still intrigued. I can't believe it. Anyway, question 6. I think this is the last one of question 6. This is the last one of the day. Montrig, yo, good night. Good night, Luanle. I hope you will watch this later when you wake up to study, since you're writing tomorrow. In the diagram below, the graph of f of x is negative 2 cos x is drawn in the interval. Okay, I see it. 6.1. Write down the amplitude of f. Now, to get the amplitude, you must go to the center of the graph, the middle of the graph, and then measure the distance from the middle of the graph to the top or the bottom of the graph. I can see there it is 2. So I'll just say amplitude is equals to 2. Did anybody get it? Nope. Nobody got it. And then 6.2, write down the range of f of x plus 3. So what we have to do here is go to see where the graph ends. See the new amplitude. So what's happening here is that we are actually moving the graph. Let me just redraw it a little bit here. Let's say my graph is okay. It's my original graph is like this. So it is currently sitting at -2 here, and at the top it's sitting at +2. Now it's saying here I shift the entire graph by 3 units up. Okay, so 3 units up. If I go 3 units here, I will go 1, 2, 3, and it ends at 1. Agreed? For this one, it's going to move 1, 2, 3. So it's 2, 3, 4, 5, and it ends at 5. Which means my range, first of all, my range has to do with y values. Put these inequality signs. They're always going to be there. And then you're going to put, it starts at 1. So 1, you put it on the left, and it ends at 5. So the new graph is going to oscillate between 1 and 5. Okay, it's going to oscillate between 1 and 5. So that's your final answer. There are many ways to write this. If you prefer, you could have just written y is an element between 1 and 5. Okay, the last thing I want us to talk about is actually, is it equals there as well? Okay, is it equal? Now, because the graph touches this point of 1, I must make it equal. Because this touches that 5, the graph touches, I must make it equal. Now, if I do that, these brackets must change into square brackets. If you're doing this format here, you must change them to square brackets. Very good. On the same system of axes, draw the graph sine x plus 30. Okay, let's try that real quick. 6.3. X plus 30 will look like this. Actually, yes, it'll be quicker if I actually, let me grab it from this side. Let me copy this, and then let me erase that. Let's see if I can paste it here. Right, it's not what I want. It's not gonna, is it gonna work out? Let's just paste. Ooh, it's messy. Just clean it a little bit. There we go. Okay, so they want me to draw. Now let's start with the mother function of a sine graph. The mother function of a sine graph, it starts at 0 and 0, and it goes to 90. And then at 180, it is 0. So it goes like that. This is now the mother function. And then at 90, it's there. This is the mother function. Now to draw this one, this is a horizontal shift. And a horizontal shift, if it's plus 30, that means we must shift it. Let me see your. We must shift it to the left. A positive number is a shift to the left by 30 units. So let's start with this point here. 0, it must move by 30 units. This is 15 here, and this is 30 there. So this point moves to there on the left. This one must also move 30 units to the left, which is this point here. So it's going to move over there. Okay, this one moved there. This one must move there. This one as well must move by 30 units to there. And then I join these points, just like that. The graph shifts 30 units. And the last thing you need to do is wrap the mother function, because you don't need it. They only needed this red one. Now this is the graph of g, which g of x, which is equals to sine x plus 30. Okay, so to do horizontal shifts, you must start with the mother function. Okay, there we go. So when using the calculator to plot 6.3, the start will be 0 and 360 and 30 will be the step. 3.6 on the same. Oh, that's if you're using a calculator. Yeah, I prefer you use the mother function. It's much easier. The calculator can get a bit confusing, but if you know how to use the calculator to draw this graph, then yeah, sure, go ahead, do it. Okay, the next question says, write the equation of h. Okay, so this time I'm on 6.4. I'm looking for the equation of h of x is formed by shifting g. Okay, so g of x currently is sine x plus 30. Okay, and then they say shift g 60 units to the left. Remember, a shift to the left is plus 60. Okay, a shift to the left is a positive number, so we say plus 60 because you shifted it to the left. And then we also move it 2 units down. So 2 units down is just minus 2 outside. Okay, so then my final answer then is h of x is equals to sine, open bracket, x. What's 30 plus 60? It is 90. And then a shift down is minus 2. If you like, you can leave this answer as it is right now, or you can simplify further. Well, I would actually simplify further just to show a bit of understanding of this topic. This is a coratio. sign changes to cos, and in this quadrant it's positive x, and then this minus 2 stays exactly as it is. This is my simplified answer, so I leave it right there. Ladies and gentlemen, the time now is 7 o'clock. I am tired. We are done with 2 topics. We are left with Euclidean. I am not writing an exam for 3 hours. I see now why your exam is 3 hours, because this hour that we need now is the hour that we would need in the exam for Euclidean. So what I can do is I can give you these questions, right? And then well, let's just choose some of them. We can rock them in the next 10 minutes. The ones that are really, really important, I'll just highlight them. But I will give you this document if you want it. But let's look at it briefly. I'm not going to do all of them. Okay, in the diagram, PA, always PA, there's PA. And
You look blurry on the screen.
oh, it's because I look blurry. I move back and forth. The camera is still trying to readjust. I look blurry. Okay, and P. Now, when you do Euclidean questions, you have to read the statement and then kind of highlight the clues that they are giving you. So they say in the diagram, PA and PB are tangents to the circle at center M. Okay, so both of them are tangents. Okay, and they come from point P. That means that PB is equals to PA. Okay, they're both tangent. Remember that rule, tangent from the same point. And then they say C is the midpoint of arc AC. So C is the midpoint of these arcs. That means BC is equals also to CA. Okay, they are equal. They are equal as well. Okay, let's continue. And then C is the midpoint of okay, I just read that. And then PQ is parallel CB. Where's PQ? PQ, okay, at least this one they showed it to us. There it is. It's parallel to that one. So once they're parallel, I must then look I have this angle. I'm looking at alternate angles first using these 2 parallel lines. That means this, I haven't even looked at the question, is equals to that. And then looking at also with parallel lines, we have a F. Remember, parallel lines are fun. So we look for corresponding angles. This angle here is equals to that angle there. These are corresponding. Also a co-interior. Well, it's not exactly. Okay, it is also given that PAC, let's see. Oh, this angle here is X. So this is the angle X. So 7.3.1 says, wait, what's 7.2? Oh, 7.3.1 says write down with reasons 5 more angles, each equals to X. So we are now on question 7. Question 7, 7.3.1. Okay, so first of all, using the 10 chord theorem. Remember 10 chord theorem? There's my triangle. It's like this. Okay, and then I have this tangent down here. 10 chord theorem says the angle between the tangent and the chord is equals to the angle opposite that chord there. So I can see using this one, this law here, that actually the angle of A1 is equals to the angle, and this triangle, it has to be inside the circle. So this is, I'm looking at the triangle A, B, and C. Yes, it's the only one that's inside the triangle. So it's equals to B1, and it's equals to X. And for each statement, you give a reason. The reason is because of 10 chord theorem. 10 chord theorem. Okay, good. Oh, hold on, is that B1? Yes, it's B1. And then I'll do the same here. Okay, so I've got B1, it's equals to X. Also, the other thing equals to B1, remember these two are equal. That means A2 is equals to B1, which is also equals to X. And the reason is because of that rule where you have an isosceles triangle, equal angles, opposite sides, or opposite sides, equal angles, opposite sides, equal angles. Just write it like that because these two lines are exactly the same. Now, if B2 is equals to it, what other one can I get? What was this? B1. Okay, B1 is equals to A2. Also, if we look very closely, now we have found, why did I just do B2 again? Oh, it's A2, my bad. Okay, so A2, if we look at A2, using the 10 chord theorem, using this other tangent now, it is equals to B2. So I can say B2 is equals to A2, and the reason is the same reason, which is equals to X because of the 10 chord theorem. 10 chord theorem. Okay, so the tangent I'm using now is BP. Okay, the angle between the tangent and the chord and the angle opposite that chord are equal. So A2 is equals to B2. Okay. Now, what is B2 equals to? Oh, B2 is equals to P1. So I can say P1 is equals to B2, which is also equals to X. Why is that? Alternate angles. These are alternate angles. Technology is now moving itself. Alternate angles. Now, when you mention alternate angles, mention the parallel lines. Please just try to rewrite it like they gave you in the question. Parallel lines is PQ, is parallel CB. That's it. How many have I found now? Now notice I use one to find the other. Okay, like I used, if you notice my pattern here, I found A1, I found B1, okay, and then I use B1 to find A2, and then I use A2 to find B2, and then I use B2 to find P1, those vibes. So sometimes these things, they go in order. Do I have 5? It looks like it. Ooh, my paper is still saving. What is it doing? It says it's not responding. Let's count how many I used. I found let's use green. I found 1, 2, 3, 4. Okay, so I found 4, which means I need one more. Okay, so P1, what can I use for P1? Okay. Oh, there's one more here. Q. Remember Q, we wrote it, that's why we write clues at the beginning. I see that Q is equals to B1. So I'm just gonna say Q, this is my 5th one now. I'm gonna say Q is equals to B1, which is equals to X. And why is that? That's because of corresponding angles now. Corresponding angles from the parallel lines, PQ is parallel CB. So you kind of have to keep on looking for these clues. All right. The next one says prove that AB. So what I'm going to do is just highlight what they are telling me to. AB, where's A? A to B, RP, and then R, and then P is a cyclic quad. Theoretically speaking, there are more or less 3 ways to prove a cyclic quad. Either I prove that I've got two angles coming from subtended from the same chord. Let's say I have that chord being here. Both these angles are equal. That's one way. The other way is to prove that the opposite sides are supplementary. If that doesn't work, let's just stick to 2. But the third one is that we have to prove external angles, that this angle is equals to that one. I have to use one of them. Okay, so let's see. Here, looking at this one, I'm going to say, okay, let's start with this first one off. It has 4. It has 4 chords. Let's start with the chord BR. BR, I have P1. It also subtends A2. Oh, we solved these ones and we said actually they are all equals to X. Oh wow, we got lucky just on our first try. So we can say P1 is equals to A2. Therefore, A, B, how do they give it? R, P is a cyclic quad. Then you have to give the reason. This is what we call converse. And what's this rule? Same segment or angles from the same chord. Let me write that one. Angles from the same chord. Angles from what's happening here? from the same chord. I can name the chord. I can say that chord is actually BR. Okay, so those are the three ways to prove cyclic chords. If you can just prove one of them, then you are done. Just like we are done with proving this cyclic chord. Okay. Let's continue. I'm blurry. Am I still blurry? Oh, I'm fine now. I'm so tired. What else do we have? I just want to show you the important ones that have the most marks. Okay, let's look at question 8 now. Question 8. So question 8 says ABC is a tangent to the circle ABC. Okay, here are the points they mention. PQ is parallel BS. PQ, okay, they showed it to us. There it is. Oh, hold on. I like to highlight even though they showed us. So these are parallel. QR is equals to RS. Oh, there we go. They showed us. S1 is 30. B3 is 70. Calculate with reason the size of the following. Okay, let's do that. 8.1. For 8.1, we are now looking for B1. Okay, where's B1? B1 is over there. Let me see your comments. What? Nothing. You're fine now. Oh, thank you, Landry. Okay, let's now look at B1. Okay. All right. So if we look at B1, this is a tangent, right? That means this angle is equals to 10 chord. Here's the chord, and we look at the triangle, not the cyclic chord. It's equals to this angle here. Okay, let's just write that immediately. B1 is equals to 30. Oh no, first I like to start with the variable, with the angle that I'm given, which is S1, which is equals to 30. And the reason is 10 chord theorem. 8.2, it says, what are we looking for now? P2. P2, where's P2? P2 is right over there. Okay, how can we look at P2? So if you look, what's the relationship between S1 and P2? You can see they're alternating. So P2 is equals to S1, which is equals to 30 degrees. And this time it's alternate angles. And when you mention alternate angles, you must say the parallel lines. Write it exactly like how they wrote it in the question. PQ is parallel BS. There we go. And then 8.3, they want R. Okay, so look at this. Currently, we know that this is 30. And if I highlight this triangle over here, no, I'm going to highlight a cyclic quad this time. P, S, R, Q, and I go all the way to P again. You can see that these two, P is opposite R. So I can say, I'm looking for R. So I can say P2 plus R is equals to 180. Opposite angles of cyclic quad. They are supplementary. You can complete and say supplementary, but it's enough just to say that. Now let me substitute. P2 is actually 30 because we solved it, right? Let me just wait for software to stop. Okay, let me check the comments so far. Nothing. 80 minus 2 is actually mentioned. You can actually see that this side is equals to that side. We just solved, which is 150. And we have a triangle here. As the triangle I'm looking at, let me just wrap these highlighted parts so that you see the triangle I'm working with now. Triangle I'm working with is SQR. Okay, so that's the triangle I'm working with. So this is now 8.4, and I am looking for Q2, right? Yes, Q2. I'm just gonna put it once and say Q2 is equals to, first of all, I'm gonna say 180 minus 150, and then divide the answer by 2. Why? This is sum of angles in a triangle. Okay, you can still do it the long way or do it this short way. It's okay. Let me bring out my calculator. I don't want to think too much, so I'll just punch it in. These are my marks I'm dealing with. Don't want to leave things into chance, so let's make sure. Divide by 2, and it is 15. Okay, so that's 150 plus 15 plus 15. Just, yeah. Okay, why after commenting it gives me problems? Bokamoso. Yeah, it got better right now. You got the answer correct, Bokamoso. Okay, so that's that. I want to highlight that. Let's see. Oh, I'm so tired, guys. Oh. Give a reason why. You know what? It's too much. I'm done. Anyway, what we just did has the most marks. These type of questions where you're looking for other angles, they have the most marks. And also these types of, this question you will always get as well, where you have to prove a cyclic quad. So what we've done already is top. You are on your own, guys. You are on your own. You have to figure these things out. I like these parallel ones because this is not great trig. I like it because 8 and 7, what we're doing was grade 11 trig, which has the most marks. How much time? Okay, let's just take 5 minutes more. But I'm really tired. Give a reason why GFM is equals. Normally I would read this whole statement just to understand what's going on. So, which is what you should do in your test, in your exam. Give a reason why is, let me just look at it. It's lagging. Whoa, if it's lagging, that's a sign. That is a sign. That's a sign that we should end this lesson. If you want the memorandum, I can give you. It's a sign indeed. It's a sign that we should end the lesson. I agree, Luanze. Yeah, we've been doing a whole lot of work. Guys, let's stop now. Stop sharing. It's me and you now. And the only thing I want to say is goodbye and all the best for your exam tomorrow, your tune exam. Hopefully, you will ace it. But remember, you do your best. You do your best. Do your best. Okay. Don't leave any question unanswered. You never know what marks you might get. Okay. All right then. Goodbye, Luantle. Goodbye, Neo. Goodbye, Selekani. Goodbye, guys. Goodbye, Bokamuso. Appreciate you too. Selekani. Goodbye, guys. All the best. Let me go eat.